Hey everyone, and welcome. Today, we're going to talk about this quiet revolution that's been happening right inside our search bars. Seriously, we're moving way beyond just matching keywords to something so much smarter, actually understanding meaning. This is the story of how AI finally taught computers to read. But let's kick things off with a feeling I'm sure you all know. You type what you think is a perfectly clear question into a search engine, and the results that come back are just bizarre. Why does that happen? Why do some of our most advanced tools sometimes feel so, well, dumb? Check this out. A perfect real-world example of what I'm talking about. Someone searched, "What is DEET?" You know, the insect repellent? And the results are about bushcrafting and cat skiing. So what on earth went wrong here? Well, the search engine got totally fixated on the words "what is" and completely missed the whole point, the actual concept of DEET. It's a classic case of keyword matching just falling flat. And that right there gets to the very heart of the problem. See, traditional search wasn't built to understand ideas. It was built to find matching strings of characters. It had no clue you were asking about a chemical compound. It only knew you typed the letters DEET. It was literally searching for strings, not the things those strings are supposed to represent. Okay, so how do we fix this? We have to actually teach the machine to understand. And the way we do it is, well, it's surprisingly a lot like how a human child learns a language. Not by memorizing a dictionary, but by just absorbing a massive, massive amount of context. This quote really nails the core idea. I mean, think about it. How did you learn what a dog is? It wasn't from one definition. You've seen them, you've read stories about them, you've heard them bark. You've built this rich, dense, complex map of the concept in your head. Well, AI models, specifically these things called transformers, do something very similar by basically reading the internet, like all of Wikipedia, millions of books, to build their own dense representation of concepts. So, how does a computer actually store this understanding? This is the cool part. It's not magic, it's math. The key technology here is something called an embedding, and it's basically the bridge that connects our human language to the computer's logic. An embedding is, for all intents and purposes, a numerical fingerprint for meaning. It can take any concept, a single word like climbing, a whole sentence, even an entire document, and it translates it into a big list of numbers. And that list of numbers, called a vector, acts like a coordinate, pinpointing that concept's exact location on a giant map of meaning. And this is where it gets really, really cool. On this map of meaning, things that have similar meanings have almost identical numerical fingerprints. Just look at the chart. Raining hard and wet outside. They're conceptually close, right? So they get a high similarity score. But raining hard and cars drive fast, totally different ideas, so they get a low score. Now look at climbing versus climber. A super high score. The machine gets that they're related, even though the words are different. They're true neighbors on this meaning map. So this is the fundamental shift we're talking about. The old way, keyword search, used what are called sparse vectors. It was basically just a simple checklist of which words were present. The new way, semantic search, uses these dense vectors, the embeddings. It's not about matching words anymore, it's all about finding the closest meaning, even if the words themselves are totally different. Okay, so we've got this incredible map of meaning. Awesome. But you can probably see the new problem, right? If you've got millions, maybe billions of documents, how on earth do you compare your search's meaning coordinate to all of them in that split second we all expect from a search engine? The process itself is pretty logical. First, all the content out there, articles, websites, you name it, gets converted into these embeddings. Then all those embeddings are organized into that searchable meaning map, which is technically called a vector index. When you type in a search, your query also gets turned into an embedding. And then the system's only job is to find the closest neighbors on that map. But again, how does it do that last step so darn fast? The answer is a really brilliant shortcut called approximate nearest neighbor, or ANN for short. Instead of painstakingly checking every single coordinate on the entire map, the system is smart. It first figures out the right neighborhood of meaning. So if you're asking about mountain hiking, it's not going to waste any time looking at documents over in the ocean life neighborhood. It's a clever, targeted search that makes what seems impossible totally possible. But I know what you're thinking. The word approximate can sound a little scary. We want speed, for sure, but we can't just throw accuracy out the window, right? This is where the final crucial piece of the puzzle comes in, a two-step process that gives us the best of both worlds. First up, we use something called a by encoder.
Think of this as the fast scan. It looks at the meaning of your query and the meaning of the documents separately to quickly whip up a big list of potential matches. Then, and only for that short list, we bring in the heavy hitter, the cross-encoder. This is the deep dive. It actually looks at your query and each document together, analyzing the shared context for a super precise relevance score.
So the winning strategy is this perfect combination. The by encoder, using that lightning-fast ANN search, zips through millions of documents to find, say, the top 100 most likely results. Then, the much slower but way more accurate cross-encoder only has to analyze that small list of 100 to re-rank them into the perfect order for you. And this just shows you how ridiculously effective this whole two-step dance is. That final re-ranking step is so powerful that, as you can see, it often helps the system regain 100% of the accuracy that might have been lost during that initial high-speed, approximate search. We get all the speed without sacrificing any of the precision. It's a win-win. So the big takeaway here is that search isn't just about finding a list of blue links anymore. It's about understanding what you truly mean. And now that our machines can actually grasp meaning, what does that unlock? I mean, will our searches become actual conversations? Will we get instant summaries instead of just lists? We've finally made the jump from matching strings to understanding things, and honestly, that changes everything about how we're going to find knowledge.